Welcome to the DIY Honda Garage channel. The DTC P2564 indicates a low voltage condition in the Turbocharger Wastegate control actuator position sensor circuit. This code is particularly critical as it relates to how the vehicle's turbocharger regulates exhaust flow, affecting engine performance and emissions. The component involved is the Wastegate control actuator position sensor, which is situated on the turbocharger assembly. Its primary function is to inform the powertrain control module, PCM, about the position of the wastegate. When the vehicle's exhaust pressure is too high, the wastegate opens to reduce turbo boost, helping to maintain optimal performance. The low voltage signal can lead to overboost conditions or inefficient engine operation, making it crucial to address this issue. Proper diagnostics is essential for ensuring that the vehicle operates efficiently and safely. The error description for DTC P2564 pertains to the Turbocharger Wastegate control actuator position sensor, which provides critical feedback on the wastegate's positioning. The wastegate is a device that controls exhaust flow into the turbine of the turbocharger. If the signal from the wastegate control actuator position sensor indicates low voltage, it may mean that the wastegate is not functioning as intended, potentially leading to either excessive boost or insufficient turbo response. This lack of control can significantly impair engine performance and fuel efficiency. Diagnosing this fault involves checking various parameters, including the voltage from the lift sensor, which should ideally be above 0.16 volts under normal operating conditions. When troubleshooting this DTC, it's imperative to use the Honda Diagnostic System, HDS, for accurate parameter readings and to confirm the fault before replacing any components. When diagnosing DTC P2564, it's essential to consider several possible causes. Firstly, a faulty actuator position sensor can send incorrect voltage readings to the PCM, indicating low voltage even if the system is operational. Secondly, wiring issues such as frayed wires or loose connections can disrupt the signal between the sensor and the PCM, thereby causing voltage drops. Additionally, problems with the PCM itself could lead to incorrect voltage interpretation, making it a critical area to investigate. Each of these potential issues can result in significant performance impacts, such as decreased power or increased emissions. Therefore, thoroughly inspecting the wiring, connectors, and the actuator position sensor is vital in identifying the root cause of the DTC P2564. Symptoms associated with DTC P2564 can manifest in various ways, impacting overall vehicle performance. One common symptom is poor acceleration, which occurs because the turbocharger may not be functioning correctly. When the wastegate fails to operate, it can lead to an imbalance in boost pressure, causing a delay in throttle response. Another notable symptom includes increased emissions, which can trigger environmental sensors and contribute to failing emissions tests. Furthermore, drivers may notice the check engine light illuminated on the dashboard, indicating that the engine management system has recognized a fault. These symptoms are not only detrimental to the driving experience, but could also lead to further mechanical issues if left unresolved. In the first step of troubleshooting DTC P2564, begin by turning the vehicle to the on mode, ensuring that it is not running. This allows the electrical systems to power up while preventing unnecessary engine wear. Next, check the electrical parameters using the Honda Diagnostic System, HDS, to monitor the exhaust wastegate EWG voltage from the lift sensor. Ideally, the voltage should be greater than 0.16 volts. If the current conditions meet this threshold, the failure is confirmed, and you can proceed to the next step. If not, it indicates an intermittent failure. And it's recommended to inspect for poor connections or loose terminals at both the turbocharger and the PCM, powertrain control module. Document any variations, as reproducing the failure under similar conditions can provide valuable diagnostic insight. Continuing with the second troubleshooting step for DTC P2564. First, turn the vehicle to the off lock mode to ensure safety while handling electrical components. Once the vehicle is off, disconnect the turbocharger 5P connector. This step is crucial as it isolates the wastegate sensor from the PCM. After disconnecting, turn the vehicle back to the on mode and again utilize the HDS to check the EWG voltage from the lift sensor. This value should be checked against the established threshold of less than 0.16 volts. If the voltage condition matches, it indicates a fault in the system, prompting the technician to move on to step 5. However, if it does not match, proceed to step 3 for a more focused diagnosis of potential actuator position sensor issues. The third step involves determining the potential failure area related to the turbocharger wastegate control actuator position sensor. Begin by measuring the voltage between specific test points while keeping the turbocharger 5P connector disconnected. The key test points are located at the turbocharger 5P connector terminals number 2 and number 3. You should find approximately 5.0 volts under these conditions. If the voltage is confirmed, it suggests the wastegate control actuator is faulty, and the recommended action is to replace the turbocharger unit. On the other hand, if the voltage is not approximately 5.0 volts, you will need to proceed to step 4 to check for issues with the wiring and connections in the system. In step 4, focus on checking the VCC2 line for any open circuits that may be causing the low voltage signal related to DTC P2564. Start by turning the vehicle to the off lock position for safety. Then, use the Honda Diagnostic System, HDS, to jump the SCS short circuit scenario line and wait for at least 1 minute. Next, disconnect the PCM connector E, 80P, to isolate that portion of the circuit. Check for continuity between test points 1 and 2, specifically at turbocharger 5P connector number 2 and PCM connector E, 80P, terminal number 77. If continuity exists, the VCC2 wire is functioning correctly, and a further examination of other components should be conducted. However, if continuity is absent, this indicates a break in the wire that needs to be repaired to restore proper functioning. In the last troubleshooting step for DTC P2564, the focus is on checking the DCWGL line for any short circuits. Begin by turning the vehicle to the off lock mode to ensure safety. With the vehicle off, once again jump the SCS line with the HDS, allowing for at least 1 minute. Following this, disconnect the PCM connector E, 80P, to prepare for a continuity check. Measure continuity between test points 1 and 2, specifically at turbocharger 5P connector number 4, and a suitable body ground. If the continuity is present, this indicates that the DCWGL wire is intact, and further troubleshooting may be necessary, such as substituting a known good PCM to see if DTC P2564 clears. However, if continuity is not present, you will need to repair any shorts in the DCWGL wire leading from the PCM to the turbocharger. After completing the necessary repairs for DTC P2564, a final verification step is essential to confirm that the issue has been resolved. Start by clearing the DTC from the diagnostic system using the HDS. This action resets the system and allows for real-time monitoring without the interference of prior faults. Next, conduct a test drive of the vehicle under varying conditions to ensure that the turbocharger is functioning correctly and that the wastegate is controlling boost effectively. Pay attention to acceleration response and check if the check engine light remains off. If the issue persists, further investigation may be necessary. Verifying the repair is a crucial part of the process, ensuring that every step performed leads to an effective resolution of the fault. Preventive maintenance is key to avoiding the recurrence of DTC P2564. Regular inspections of the turbocharged system should be performed, with particular attention paid to the wastegate and its sensors. Inspecting connections and wiring for signs of wear or damage can help catch issues before they lead to faults. Moreover, servicing the turbocharger annually can ensure it operates as intended, maintaining optimal performance. By adhering to a maintenance schedule, you can minimize the risk of voltage-related issues and prolong the life of your turbocharger system. Consistent checks and servicing not only enhance performance, but can also lead to improved fuel efficiency and lower emissions, aligning with best practices for vehicle maintenance. In conclusion, diagnosing and repairing DTC P2564 requires a systematic approach with an emphasis on verifying faults using the Honda Diagnostic system. Understanding the role of the turbocharger wastegate control actuator position sensor is crucial, as well as recognizing the impact of low voltage readings. Addressing any wiring issues promptly can help eliminate intermittent faults that lead to performance inefficiencies. Additionally, implementing preventive maintenance measures can ensure the longevity of the turbocharging system, leading to a more reliable driving experience. By following the outlined troubleshooting steps and maintenance recommendations, technicians can effectively restore the vehicle's performance and prevent future occurrences of this DTC. Please like and subscribe to the channel. See you next time.